Hello everyone, welcome to Nrcm, and I'm going to explain about operating system unit 3, and the topics are deadlock, system model and deadlock characterization. First of all, what is a deadlock? A deadlock is a situation in which two computer programs sharing the same resource, they're effectively preventing each other from accessing the resource. So here the result, what will be the resultant is like in both programs, both programs will be in cease function. Normally, a set of blocked processes, each holding a resource and waiting to acquire a resource held by another process in the set. It is called as the deadlock problem. Suppose consider like there are two disk drives like P1 and P2, each hold one disk drive and each needs another one. So like suppose if there are like P1 and P2 are there, they both are holding different disk drives. Then they both are holding disk drives, and each of the each of the process, like if suppose P1 is holding the disk drive called as A, and it needs the one more disk drive called as B, which is held with the P2. So this kind of problem, when this kind of problem arrives, the deadlock happens. So this is all about the deadlock. So next, coming to the system model. So what is a system model? System model is nothing but it contains the resources. Here the resources are like R1, R2 and until RM. So the resources are nothing but the resources might be like CPU, memory unit or any other input output devices. And here each resource each process will be allocated a resource. Like if process is been executing, so for each process some resources will be allocated. So initially the process should request for the resource, and then once the request is confirmed, then they will use the resource, and then later they can, after completion of the work, they can release the resource. This is all about the system model. So next, coming to the deadlock characterization. See, normally the deadlock can arise in four conditions. Like first condition is mutual exclusion, and the second is hold and wait, and third is no preemption, and fourth one is circular wait. So what is mutual exclusion? Mutual exclusion is like here only one process at a time can use a resource. So it is called as mutual exclusion, means this should not happen. So if this mutual exclusion happens, then the deadlock will arrive. Means that is if only one process at a time. So if there is a shortage of resource, so that only one process can use the resource at a time. So if other process comes, it cannot hold the same resource, right? So if this condition arrives, then we call it as a mutual exclusion. Next, second is hold and wait. Hold and wait is like if a process is holding at least one resource, and it is waiting to get the additional resources which is held by the other processes. This is called as a hold and wait. Like suppose I'm holding one resource, and without releasing that resource, I'm waiting for another resource. So once I get the other resource, then I will be releasing the resource which I'm holding. So this, if this condition is there, so if this hold and wait occurs, then deadlock will be occurring. And next is no preemption. So like no preemption is like, now what is the meaning of preemption? So preemption is like suppose like if the process is been executing by the CPU, or if process is in execution, so in the meanwhile the different process arrives which is having with the highest priority. So then what happens, the executing process will be paused or stopped. It's not stopped, it will be paused, and then the process, the newly arrived process with the highest priority will be executed. And later, once the highest priority process finished its execution, so then next the old process resumes its execution. So this is called as preemption. But here, what is the meaning of no preemption? No preemption is like a resource can be released only voluntarily by the process holding it after the process has completed its task. Like the meanings comes like here there is no value for the priority. If there is no reason for the priority, then this kind of deadlock can occur. Next is like circular wait, and before going to circular wait, I wanted to give you the example for no preemption. This is a general example. Like general example, like we all are on the roads, like some people are walking, some people are driving, some people are cycling. So what happens suddenly, like we have, I mean, we'll be getting the announcement like prime minister is passing the same way, like which we are using the way. So then suddenly what happens, all the like all the movements will be stopped and will be paused, and we'll be waiting, we'll be standing aside, right? We'll be standing aside until the, and until the cars passes away. So until then we'll be in pause state. So once the road is clear, once the cars are passed away, I mean the prime minister cars are passed away, so then again we'll resume our works. Like whoever are doing walking, they will be continuing their walking, and whoever driving, and whoever are cycling, they'll be continuing their works. So this is called as example of preemption. So no preemption means, so even though the prime minister car occur, I mean is on the way, he's on the way, but we are not stopping our works. We are not pausing our works. Okay, he will be going beside. Like some people are walking, they are driving, but he will be going beside. This is called as no preemption. At this condition, the deadlock will occur. So next, coming to the circular wait. The circular wait is like, suppose if there are n number of the process like p0 to pn, they're waiting for some resources. Okay, here what happens, so p1 has got already one resource, but it is still waiting for what, it is waiting for p1 to release that resource. Until the p1 releases the resource, the p0 will execution will not be completed. So this is called as circular wait. So and even p1 is holding its own resource, and P1 is still waiting for P2 to release the other resource which is held by the P2. So now until P2 releases the resources, so P1 will, I mean, it cannot complete its final execution. So this is all about the circular wait. So these are the deadlock characterizations. And in next class, I'll be discussing about like resource allocation graph and all. Okay then, thank you.